live on this, and I think we're also going to go live on, and we're live. Here we go. This is fun. All right, dude. We are officially live on
Thanks for having me.
YouTube. So I'm going live now on good old LinkedIn. And Robert, it's great to have you here for the Vector Space Talks. I don't know if you're familiar with some of this fun stuff that we do here, but we get to talk with all kinds of experts like yourself on what they're doing when it comes to the vector space and how you've overcome challenges, how you're working through things, because this is a very new field and it is not the most intuitive, as you will tell us more
Hmm.
in this upcoming talk. I really am excited because you've been a scientist by trade. Now you're currently founder at Emergent Methods, and you've dedicated your career to a variety of open source projects that range from the large scale AI systems to the discrete element modeling. Now at Emergent Methods, you are adaptively modeling over 1 million news articles per day. That sounds like a whole lot of news articles. And you've been talking and working through production grade RAG, which is basically everyone's favorite topic these days. So I know you got to talk for us, man. I'm going to hand it over to you. I'll bring up your screen right now. And when someone wants to answer or ask a question, feel free to throw it in the chat and I'll jump out at Robert and stop him if needed. So
Sure.
great to have you here, man. I'm excited for this one.
Thanks for having me, Demetrios. This it's a great opportunity. I love talking about vector spaces, parameter spaces. It's so to talk on the show is great. We've got a lot of fun challenges ahead of us in the industry, I think, and the industry is establishing best practices, like you said. Everybody's just trying to figure out what's going on, and some of these base layer tools like Qdrant really enable products and enable companies, and they enable us. So let me start. Like you said, I'm Robert, and I'm the founder of Emergent Methods. We our background, like you said, we are really committed to free and open source software. We started with a lot of narrow AI. Freak AI was one of our original projects, which is AI ML for algo trading, very narrow AI. But we came together and built Flowdapt. It's a really nice cluster orchestration software, and I'll talk a bit about that during this presentation. But some of our background goes into, like you said, large scale deep learning for supercomputers. Really cool, interesting stuff. Um, we have some cloud experience. We really like configuration. So let's dive into it. Why do we actually need to engineer context in the news? Um, you know, there's a lot of reasons why news is important and why it needs to be distributed in a way that's balanced and diversified, but also consumable, right? Let's look at ChatGPT on the left. This is ChatGPT plus. It's kind of hanging out, searching for Gaza news on Bing, trying to find the top three articles. It's live web search is powerful, but it's slow and ultimately inaccurate. And so what we're building is real-time indexing, and we couldn't do that without Qdrant. And there's a lot of reasons, which I'll be perfectly happy to dive into. But eventually, ChatGPT will pull something together here. There it is. And the first thing it reports is a 25-day-old article with 25-day-old news. So it's just inaccurate. So it's borderline dangerous what's happening here, right? So this is a very, very delicate topic, engineering context in news properly, which takes a lot of energy, a lot of time and dedication and focus. And not every company really has this sort of resource. So we're talking about enforcing journalistic standards, right? OpenAI and ChatGPT, they just don't have the time and energy to build a dedicated prompt for this sort of thing. So it's fine. They're doing great stuff. They're helping you code, but Someone needs to step in and really do enforce some journalistic standards here. And that includes enforcing diversity, languages, regions, and sources. If I'm going to read about Gaza, what's happening over there, you can bet I want to know what Egypt is saying and what France is saying and what Algeria is saying. So let's do this right. That's kind of what we're suggesting. And the only way to do that is to parse a lot of articles. That's how you avoid outdated, stale reporting, and that's a real danger, which is kind of what we saw on that first slide. Um, no, everyone here knows hallucination is a problem, and it's something you got to minimize, especially when you're talking about the news. It's just a really high cost if you get it wrong, and so you need people dedicated to this. And if you're going to dedicate a ton of resources and a ton of people, you might as well scale that properly. So that's kind of where this comes into. We call this context engineering, news context engineering to be precise. Before Llama 2, which also is enabling products left and right, as we all know, the traditional pipeline was, chunk it up, take 512 tokens, put it through a translator, put it through DistillBart, do some sentence extraction, and maybe text classification if you're lucky, get some sentiment out of it. And, it works, it gets you something, but after, we're talking about reading full articles, getting real rich context, um, flexible output, translating, summarizing, really deciding that custom extraction on the fly as your product evolves. That's something that the traditional pipeline really just doesn't support, right? We're talking being able to on the fly say, you know what, actually, we want to ask this very particular question of all articles and get this very particular field out. And it's really just a prompt modification. So, um, this all is based on having some very high quality base level diversified news. And so we'll talk a little bit more, but news catchers is one of the sources that we're using, which opens up 50,000 different sources. So check them out. That's newscatcherapi.com. They even give free access to researchers if you're doing research in this. So, I don't want to dive too much into the direct RAG stuff. We can go deep, but I'm happy to talk about some examples of how to optimize this and how we've optimized it. Here on the right, you can see the diagram where we're trying to follow along the process of summarizing and embedding, and I'll talk a bit more about that in a moment. It's here to support. Uh, After we've summarized those articles and we're ready to embed, that embedding is it's really important to get that right because like the name of the show suggests, you have to have a clean cluster vector space if you're going to be doing any sort of really rich semantic similarity searches, and if you're going to be able to dive deep into extracting important facts out of all 1 million articles a day, you're going to need to do this right. So having a user query which is not equivalent to the embedded page, where this is the data, the enriched uh, uh, data the embedding that we really want to be able to do search on, and then how do we connect the dots here? Of course, there are many ways to go about it. One way, which is interesting and fun to talk about, is high DE. So that's basically a hypothetical document embedding. And what you do is you use the LLM directly to generate a fake article, and that's what we're showing here on the right. So let's say if the user says, "What's going on in New York City government?" Well, you could say, "Hey, write me just a hypothetical summary based." It's completely fake, and use that to create a fake embedding page and use that for the search, right? So then you're getting a lot closer to where you want to go. Um, there's some limitations to this to high DE. There's a computational cost. Also, it's not updated. It's based on whatever it's basically diving into what it knows about the New York City government and just creating keywords for you. So there's definitely optimizations here as well. When you talk about ambiguity, well, What if the user follows up and says, well, why did they change the rules? Of course, that's where you can start, you know, prompt engineering a little bit more and saying, okay, given this historic conversation and the current question, uh, give me some explicit question without ambiguity, and then, you know, do the high DE if that's something you want to do. The real goal here is to stay in a single parameter space, a single vector space. Say as close as possible when you're doing your search as when you do your embedding. So, you know, we're talking here about production scale of stuff. So I really am happy to geek out about the stack, the open source stack that we're relying on, which includes Qdrant here. But let's start with vLLM. I don't know if you guys have heard of it. This is a really, really great new project, and they're focused on continuous batching and page detention. And if I'm being completely honest with you, it's really above my pay grade in the technicals and how they're actually implementing all of that inside the GPU memory. But what we do is we outsource that to that project, and we really like what they're doing, and we've seen really good results. It's increasing throughput. So, you know, when you're talking about trying to parse through a million articles, you're going to need a lot of throughput. The other is text embedding inference. This is a great server, and you know, a lot of vector databases will say, okay, we'll do all the embedding for you, and we'll do all the everything. But when you move to production scale, I'll talk a bit about this later. It's really, you need to be using microservice architecture. So it's not super smart to have your database bogged down with doing hand sorting out the embeddings and sorting out other things. So honestly, I'm a real big fan of single responsibility principle. And that's what TEI does for you. And it also does dynamic batching, which is great in this world where everything is heterogeneous lengths of what's coming in and what's going out. So it's great. It really simplifies the process and allows you to isolate resources. But now, you know, the star of the show, Qdrant. You know, it's really come into its own. Anyone riding the quadrant wave is just reaping benefits. It seems monthly. You know, like 2 months ago, sparse vector support got added. There's just constantly new massive features that enable products, right? Um, so for us, yeah, we're doing so much upsert. We really need to minimize client connections and networking overhead. So you got that batch upsert. The filters are huge. You know, we're talking about real-time filtering. You know, we can't be searching on news articles from a month ago, 2 months ago, if the user is asking for a question that's related to the last 24 hours. So having that timestamp filtering and having it be efficient, which is what it is in Qdrant, is huge. Keyword filtering is really opens up a massive realm of product opportunities for us. And then the sparse vectors, you know, we hopped on this train immediately and are just seeing benefits. You know, I don't want to say replacement of Elasticsearch, but well, Elasticsearch is using sparse vectors as well. So you can add Splade into Elasticsearch, and Splade's great. It's a really great alternative to BM25. It's based on that BERT architecture, and that really opens up a lot of opportunities for filtering out keywords that are kind of useless to the search when the user uses the and a, and then these words that are less important. Splade's a bit of a hybrid into semantics, but sparse retrieval. So it's really, really, really interesting. And then the idea of hybrid search with semantic and a sparse vector also it opens up the ability to do, you know, ranking, and it's just you got a higher quality product at the end, which is really the goal, right? Especially in production. Um, you know, point number 4 here, I would say, is probably the one of the most important to us, because we're dealing in a world where latency is king, and being able to deploy Qdrant inside of the same cluster as all the other services. So we're just talking through the switch. That's huge. You know, we're never getting bogged down by network. We're never worried about a cloud provider potentially getting overloaded or noisy neighbor problems, stuff like that, completely removed. And then you got high privacy, right? All the data is completely isolated from the external world. So point number four, I'd say, is one of the biggest value adds for us. But then, distributing deployment is huge, because high availability is important, and deep storage, which when you're in the business of news archival, and that's one of our main missions here, is archiving the news forever. That's an ever growing database, and so you need a database that's going to be able to grow with you as your data grows. So what's the TLDR to this context engineering? Well, service orchestration it's really just based on service orchestration in a very heterogeneous and parallel event-driven environment. On the right side, we've got the user requests coming in. They're hitting all the same services, which every 5 minutes or every 2 minutes, whatever you've scheduled the scrape workflow on, also hitting the same services. This requires some orchestration. So that's kind of where I want to move into discussing the real production, scaling, orchestration of the system, and how we're doing that. Provide some diagrams to demonstrate, to show exactly why we're using the tools we're using. Here, this is an overview of our Kubernetes cluster with the services that we're using. So it's a bit of a repaint of the previous diagram, but a better overview about showing kind of how these things are connected and why they're connected. And I'll go through one by one on these services to just give a little deeper dive into each one. But the goal here is, for us, in our opinion, microservice orchestration is key. Sticking to single responsibility principle, open source projects like Qdrant, like TEI, like vLLM, and Kubernetes, it's huge. Kubernetes is opening up doors for security and for latency, and of course, if you're going to be getting involved in this game, you got to find a strong DevOps. So there's no escaping that. So let's step through kind of piece by piece and talk about Flowdapt. So that's our project. That's our open source project. We've spent about 2 years building this for our needs, and we're really excited because we did a public open sourcing maybe last week or the week before. So finally, after all of our testing and rewrites and refactors, we're open for business, and it's running AskNews.app right now, and we're really excited for where it's going to go and how it's going to help other people orchestrate their clusters. Our goal and our priorities were highly parallelized compute, and we were running tests using all sorts of different executors, comparing them. So when you use Flowdapt, you can choose Ray or Dask, and that's key, especially with vanilla Python, zero code changes. You don't need to know how Ray or Dask works in the back end. Flowdapt is vanilla Python. That was a key goal for us to ensure that we're optimizing how data is moving around the cluster. Automatic resource management, this is a bit, this goes back to Ray and Dask. They're helping manage the resources of the cluster, allocating a GPU to a task or allocating multiple tasks to one GPU. These can come in very, very handy when you're dealing with very heterogeneous workloads like the ones that we discussed in those previous slides. For us, the biggest priority was ensuring rapid prototyping and debugging locally. When you're dealing with clusters of 10, 15 servers, 40 or 50, 100 with Ray, honestly, Ray just scales as far as you want. So when you're dealing with that big of a cluster, it's really imperative that what you see on your laptop is also what you are going to see once you deploy, and being able to debug anything you see in the cluster is big. For us, we really found the need for easy cluster-wide data sharing methods between tasks. So essentially what we've done is made it very easy to get and put values. And so this makes it extremely easy to move data and share data between tasks, and make it highly available and stay in cluster memory, or persist it to disk, so that when you do the inevitable version update or debug, you're reloading from a persisted state. in the real-time news business, scheduling is huge. Scheduling, making sure that various workflows are scheduled at different points and different periods and or frequencies rather, and that they're being scheduled correctly, and that they're triggered. Their triggers are triggering exactly what you need when you need it. Huge for real time. And then one of our biggest um, selling points, if you will, for this project is Kubernetes style everything. Our goal is everything's Kubernetes style, so that if you're coming from Kubernetes, everything's familiar, everything's resource oriented. We even have our own, Flowectal, which would be the kubectal style command schemas. You know, a lot of what we've done is ensuring deployment cycle efficiency here. So the goal is that Flowdapt can schedule everything and manage all these surfaces for you, create workflows. But why these services for this particular use case? I'll kind of skip through quickly. I know I'm kind of running out of time here, but of course you're going to need some proprietary remote models. That's just how it works. You're going to, of course, share that load with on-premise LLMs to reduce cost and to have some reasoning engine on premise. But there's obviously pro advantages and disadvantages to these. I'm not going to go through them. I'm happy to make these slides available, and you're welcome to kind of parse through the details. Yeah, for sure, you need to start thinking about persistence and search and making sure those services are robust. That's where Qdrant comes into play. And we found that the all-in-one solutions kind of sacrifice performance for convenience or sacrifice accuracy for convenience, but it really wasn't for us. We'd rather just orchestrate it ourselves and let Qdrant do what Qdrant does instead of kind of just hope that an all-in-one solution's handling it for us. And that allows for modularity, performance, and we'll dump Qdrant if we want to. Probably we won't, or we'll dump Minio if we need to, or we'll swap out for whatever replaces vLLM. Trying to keep things modular so that future engineers are able to adapt with the tech that's just blowing up and exploding right now, right? The last thing to talk about here in a production scale environment is really minimizing the latency. I touched on this with Kubernetes, ensuring that these services are sitting in the same on the same network, and that is huge. But that talks about the communication latency. But when you start talking about getting hit with a ton of traffic, production scale, tons of people asking a question all simultaneously, and you needing to go hit a variety of services. Well, this is where you really need to isolate that to an asynchronous environment. And of course, if you could write this all in Golang, that's probably going to be your best bet. For us, we have some services written in Golang, but predominantly, especially the endpoints that the ML engineers need to work with, we're using Fast API on Pydantic, and honestly, it's powerful. Pydantic v2.0 now runs on Rust, and as anyone in the Qdrant community knows, Rust is really valuable when you're dealing with highly parallelized environments that require high security and protections for immutability and atomicity. Forgive me for pronunciation. That kind of sums up the production scale talk, and I'm happy to answer questions. I love diving into this sort of stuff. I do have some just general thoughts on why startups are so much more well positioned right now than some of these incumbents. And I'll just do kind of a quick run through, less than a minute, just to kind of get it out there, and we can talk about it, see if we agree or disagree. But you touched on it, Demetrios, in the first in the introduction, which was the best practices have not been established. That's it, and that is why startups have such a big advantage. And the reason they're not established is because, well, the new paradigm of technology is just underexplored. We don't really know what the limits are and how to properly handle these things. and that's huge. Meanwhile, some of these incumbents, they're dealing with all sorts of limitations and resistance to change and stuff. And yeah, I mean, and then just market expectations for incumbents maintaining these kind of legacy products and trying to keep them hobbling along on this old tech. In my opinion, startups reason you got your reasoning engine, building everything around a reasoning engine, using that reasoning engine for every aspect of your system to really open up the adaptivity of your product. And okay, I won't put Elasticsearch in the incumbent world. I'll keep Elasticsearch on this in the middle. I understand it still has a lot of value, but some of these, vendor lock-ins, we're not a huge fan of. But anyway, that's it. That's kind of all I have to say. But I'm happy to take questions or chat a bit. Yeah,
Yes.
let me.
Dude, I've got so much to ask you, and thank you for breaking down that stack. That is like the exact type of talk that I love to see because you open the kimono full on. And I was just playing around with AskNews.app, and so I think it's probably worth me sharing my screen just to show everybody what
Sure.
exactly that is and how that looks at the moment. So you should be able to see it now, right?
Hmm.
And super cool. Props to you for what you've built because I went and intuitively I was able to say like, oh, cool. I can change. I can see like positive news and I can go by the region that I'm looking at. I want to make sure that I'm checking out all the stuff in Europe or all the stuff in America, categories. I can look at sports, blah, 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 like as if you were flipping the old newspaper and you could go to the
Yeah.
sports section or the finance section and then you cite the sources and you see like, oh, what's the trend in the coverage here? What kind of coverage are we getting? Where are we at in the coverage cycle? Probably something like that. And then, wait, although I was on the like happy news, I thought, and
Yeah,
in
it's
there
a good.
murder, she wrote. So, so anyway,
What
they're
we do
in.
is we actually sort it from we take the poll and we actually just sort most positive to the least positive. But you're
Oh, I
right.
see.
We were talking the other day. We're like, let's just only show the positive. But yeah, that's a good point.
There you go.
Murder she wrote.
But the one thing that I was actually literally just yesterday talking to someone about
Mm,
was how you update things inside of your vector database. So
mm,
I can imagine that news, as you mentioned, news cycles move very fast. And the news that happened 2 hours ago is very different. The understanding of what happened in a very big news event is very different 2 hours ago than it is right now. So, how do you make sure that you're always pulling the most current and up to date information?
mm. This is another logistical point that we think needs to get sorted properly. And this there's a few layers to it. So for us, as we're parsing that data coming in from newscatcher, so newscatcher is doing a good job of always feeding the latest buckets to us.
Hmm.
Sometimes one will be kind of arrive, but most generally speaking, it's always the latest news. So we're taking 5 minute buckets, and then with those buckets, we're going through and doing all of our enrichment on that,
Oh, wow.
adding it to Qdrant. And that is the point where we use that timestamp filtering, which is such an important
Oh,
point.
I
So
see.
in the metadata of Qdrant, we're using the range filter, which is where we call that the timestamp filter, but it's really a range filter. And that helps. So when we're going back to update things, we're sorting and ensuring that we're filtering out only what we haven't seen.
Okay, that makes complete
Mm,
sense. And you could basically you could generalize this to something like what I was talking to with people yesterday about, which was, hey, I've got an HR policy that gets updated every other month or every quarter,
mm,
and I want to make sure that if my HR chatbot is telling people what their vacation policy is, it's pulling from the most recent HR
mm,
policy. So how do I make sure and do that? And how do I make sure that my vector database isn't like a landmine where it's
mm.
pulling any information, but we don't necessarily have that control to be able to pull the correct information? And this comes down to that retrieval evaluation, which is such a
Mm.
hot topic too.
Yeah, it's true. No, I think. that's a key piece of the puzzle. Now, in that particular example, maybe you actually want to go in and start cleansing a bit
Mhm.
your database just to make sure if it's really something you're never going to need again, you got to get rid of it.
Yeah.
This is a piece I didn't add to the presentation, but it's tangential. You got to keep multiple databases, and you got to be keep making sure to isolate resources and cleaning out a database, especially in real time. So ensuring that your database is representative of what you want to be searching on. And you can do this with collections too if you want, but we find there's sometimes a good opportunity to isolate resources in that sense.
100%. So another question that I had for you was, I noticed Mongo was in the stack.
Hmm.
Why did you not just use the Mongo vector option? Is it because of what you were mentioning, where it's like, yeah, you have these all-in-one options, but you sacrifice that performance for the convenience?
Um, we didn't test that, to be honest, and so I can't say. All I know is we tested Weaviate, we tested one other, and I just really like Qdrant. I really like. I think although I was going to say I like that it's written in Rust, although I believe Mongo is also written in Rust, if I'm not mistaken. Um, but for us, the document DB is more of a representation of state and what's happening, and especially for our configurations and workflows. And meanwhile, we really like keeping and relying on Qdrant and all the features Qdrant is updating. So yeah, I'd say single responsibility principle is key to that. Um, but I saw some chat in Qdrant Discord about this, which I think the only way to use Vector is actually to use their cloud offering, if I'm not mistaken. Do you know about this? Or
Yeah, I think so
okay,
too. I
this would
think,
also be a piece that we couldn't do. So
yeah, where it's like it's open source but not open source, so that makes sense.
yeah,
Yeah, this has been excellent, man. So I encourage anyone who is out there listening, check out, again, this
thanks.
is AskNews.app, and stay up to date with the most relevant news in your area and what you like. Is there, and I signed in, so I'm
Nice.
guessing that when I sign in, it's going to tweak my settings. Am I going to be able
Good
to just
question.
catch this next time?
So, well, at the moment, if you star on a story, a narrative that you find interesting, then you can filter on the star, and whatever the latest updates are, you'll get it for that particular story. Um,
Oh, nice. Okay.
it brings up another point about Qdrant, which is at the moment we're not doing it yet, but we have plans to use the recommendation system for letting a user kind of create their profile by just saying what they like, what they don't like,
Mhm.
and then using the recommender to start recommending stories that they may or may not like. And that's us outsourcing the Qdrant almost entirely, right? It's just us building around it, so that's nice.
Yeah, that makes life a lot easier,
Mm, yeah,
especially knowing recommender systems.
yeah,
Well, that's
it's true.
excellent.
Thanks, I
Dude,
appreciate that, for sure. And I'll try to make the slides available. I don't know if I can send them to Qdrant or something. I could
yeah,
post them in the Discord maybe.
for
But
sure. And we can post them in the link in the description of this talk. So this has been excellent, Rob. I really appreciate you coming on here and chatting with
thanks.
me about this. And thanks for breaking down everything that you're doing. I also love the vLLM project. It's blowing up. It's cool to see so much usage and all the good stuff that you're doing with it. And yeah, man, for anybody that wants to follow along on your journey, we'll drop a link to your LinkedIn so that they can connect with
Thanks.
you. And
Cool.
thank you.
Thanks for having me, Demetrios. Talk to you
I'll
later.
catch you later, man. Take care.